Okay, so here's the first method. Now, by the way, I'm going to give you two, okay? Use whichever you like, but you have to know both, okay? I know people don't like that, especially because they're like, I hate graphing. Everyone hates graphing for some reason. But you got to know both because number one, sometimes one method is vastly faster than the other, okay? So you're just hurting yourself if you only know one. And number two, even if you know one, the other one, whichever one you use, will provide you with a really helpful sort of check to know, have I got it right or not, okay? So here's the first one, use the graph. Now we've just said the locus I'm interested in is the midpoint of the chord. So it's got to be inside the parabola, okay? Which means that from here to here, these weird crossed out ones, that can't be part of the locus, okay? There must be a restriction there, okay? So how would you suggest I find out what these 2 points are? Just solve simultaneously, because we know this equation is x squared equals 4y. We know that equation, let's solve it, okay? So I would say, and by the way, I would include this in your answer, okay? Especially with a topic like this, please avoid just having, in your head, you're like, I've got to solve simultaneously. So you write down some equations, okay? But if you haven't explained why, number one, you're going to trip yourself up. Number two, the marker is going to have no idea if you really understand what you're doing or not. So I would say to find the points of intersection. Say that again. I'm using the graph. Okay, I'll show you method 2 in a second. To find points of intersection, I'm going to solve simultaneously. So I've got 2y plus 4 equals 4y. This looks like it'll be nice and easy. 4 equals 2y, y equals 2. Okay. Usually though, it's restrictions on the domain, not restrictions on the range. Okay. Even though in this case both would work. Okay. So to get from here to my x values, I would say, therefore, x squared equals 8. Yep. So x equals plus or minus 2 root 2. Does that make sense? And that sort of looks like, it's not a beautiful graph, but that looks like it makes sense, okay? Now, these are the points of intersection. So what does that tell me about the restriction? How do I use this to express my restriction? Good. This is the negative one, right? So I want to be on the left here, and this is the positive one. I want to be to the right of that, okay? So you would say, therefore, the restriction is less than the negative one, inclusive, or greater than the positive one. If you want to be super fancy, you can use absolute value notation. You can say the absolute value of x is greater than 2 root 2. Okay? Either of those would be fine. So the actual locus that I'm interested in is this equation with this restriction. And that's my answer, full stop. Okay? Now, that wasn't too hard. Yeah?
Could you use the restriction y smaller than?
I'm going to say no. The reason why is because, number one, the topic is, like, the subpoint is called restriction on the domain. Okay? Number two, because what you're looking at is if you do it as, in terms of range, you're thinking of it as a relation, not a function. Because one y value goes to 2 x values. So it can be confusing, right? So I would do the extra work and get to the x value. I really think you should do it. Okay? Yeah.
You know how on an equality you have the equal to sign?
Yeah.
You have the midpoint be on the parallel?
Yep.
Is it just when the 2 points are the same?
Yeah, it's when P and Q coincide. Okay. So their midpoint is on top of
Can't
each
it
other.
then be on the vertex of the
Oh, you mean here? Yeah, exactly right. Because then the chord would be tangent to the parabola at that point.
Oh, right.
So that chord would just be the x-axis. So it doesn't pass through 0 minus 2. Good pickup. Okay, is that all right? Okay, now I'm going to leave that there. Method number 1. Yeah?
How did you determine the signs?
You mean which way do I go?
Yeah.
Yeah, okay. So that's where, using the graph, right? You've got to use a bit of intuition. You've got to really think this through. So you've got to look at the graph and you've got to say, I want the parts of this graph that are inside the parabola, right? So I'm eliminating the part between these two. I want the parts on the outsides, right? So that's why I said to the left of the negative one and to the right of the positive one. So there's no
So it
there's
has
no
to
formula
be,
to
It
it.
has to be inside the original parabola.
Yep.
The locus.
That's right. Now, I'll give you a quick question for those of you who haven't asked the question, so I think that means you understand. Here, I said the locus has to be inside the parabola. Can you tell me a situation where the locus would have to be the reverse, where it would have to be outside? Think. You should have done some examples. Thank you. So often, let's do one down here, okay? You're going to have a tangent over here, tangent over there, right? So you can see the locus of that point of intersection, wherever it goes, must be outside, right? So you can't just blindly think, oh, gotta be inside, well, it might be outside. Think about what the locus has to do, okay? Think about where it can go and where it's restricted, right?